when we are talking about the binding energy part, so I think I told you that when one U mass gets destroyed, okay, so then
Mm-hmm.
approximately 931 mega electron volts of energy is produced. Yes or no?
Yes.
So this is, I think, this is where we left off, where I told you that 1 U is equals to 1.67 into 10 raised to power minus 27 kg, right? And energy is equals to mc square. And then we were discussing about the nuclear density.
Yes.
So I think I was supposed to start from nuclear density concept, isn't it? Right?
Um. Yeah.
As the number of protons increases, okay,
Mm-hmm.
the size of the nucleus increases. Size of the nucleus increases. Why so? Because this is a hydrogen atom. Hydrogen atom
Yes.
nucleus has only one proton.
One.
Since hydrogen atom is the smallest atom, so its nucleus is also the smallest. So
Yes.
thereby, the radius of the nucleus shall be the smallest. And what is the value of the hydrogen's nucleus radius? Hydrogen's nucleus radius, that is, we are representing with R naught, and that is
The
R naught.
is Yeah, the one
And R naught is nothing but 1.13
one three.
into 10 raised to power minus 3 meter.
Yes.
And we call 10 raised to power minus 15 meter as Fermi. So you have to remember
From
this relationship, that 1 Fermi, Fm, is Fermi. You read it as Fermi, is
Mm-hmm.
nothing but 10 raised to power minus 15 meters. It is such a small distance it is. So what do you think I should understand from this? That, ma'am, when this is happening, so when we have bigger atoms than hydrogen, so definitely their nucleus shall also be bigger than hydrogen's nucleus. So their nucleus shall also be bigger than hydrogen's nucleus. Okay?
Mm-hmm.
And thereby the radius of that bigger nucleus. So R is what? R is the radius of any nucleus, any bigger nucleus. So that shall be equals to R naught A raised to the power 1 over 3. What is A here? A here shall be mass number.
Yeah.
A here shall be mass number. What is mass number? The number of protons plus neutrons.
Protons.
That means
Neutrons. Yes.
basically the number of nucleons. You know, the number of
Mm-hmm.
nucleons. Understood or not?
Yes.
So when we are talking about this mass number P plus N, which is nucleons, I hope you're understanding that A is my mass number P plus N.
Mm-hmm.
Okay. Now, for example, we have this particular atom, let's suppose aluminium, and I want you to know the radius of the aluminium atom. So what shall I say? My formula is R equals to R naught into A raised to power 1 by 3, the cube root. So R of aluminium can be expressed in terms of the radius of hydrogen's nucleus. What is R naught? Radius of hydrogen's nucleus into A. A is what? The atomic number of aluminium, the atomic mass of aluminium raised to the power 1 by 3.
100.
So when I multiply the mass number of aluminium, that is 27 raised to power 1 by 3, into the radius of hydrogen's nucleus, that is nothing but 1.13 Fermi. So I will get radius of aluminium. So radius of aluminium shall be what? 1.13 Fermi is the radius of hydrogen's nucleus. And
Mm-hmm.
I'm trying to find out the radius of aluminium's nucleus. So that shall be what? What is 27? 27 is 3 cube. 3 times 3 times 3 is 27. And raised to power 1
Yes.
over 3. So power raised to another power shall give me what? It shall give me radius of aluminium nucleus. And it shall be 1.13 into 3, because you cancel the powers. So we are left with
Mm-hmm.
9 and 3, and 3.39 Fermi shall be what? 3.39 Fermi shall be the radius of the nucleus of aluminium nucleus. Because aluminium consists of what? It consists of 13 protons, and it also consists of 14 protons. So when 13
Mm-hmm.
protons and 14 neutrons are placed in one nucleus, definitely that nucleus is going to be bigger. And how
Mm-hmm.
much bigger? It is going to be 3.39 Fermi shall be the radius of the aluminium's nucleus. So this is how we sort of use this particular formula. Are you
Okay.
understanding?
Yeah.
You understand? So this is
Mm-hmm.
my basic concept of how you calculate the nucleus of every element. Now, for example, if I give you some element X whose atomic number is 64, whose mass number is 64. So mass number is 64, so mass number is nothing but A. And I want you to calculate the radius of the nucleus of such an element. Radius of the nucleus of element X.
Okay.
X is atom. So you know the formula now. R of
Mm-hmm.
X nucleus is equals to R of hydrogen's nucleus times A raised to power 1 over 3. So what is the radius of X nucleus shall be? The radius of hydrogen's atom's nucleus is 1.13 Fermi
Mm-hmm.
into the mass number of X is given to me as 64 raised to power 1 over 3. So R of X nucleus shall be what? It shall be 1.13 Fermi into what is 64? 64 is 4 cube raised to power 1 over 3.
Yes.
So 3 cancels 3 again. So I am taking specifically those answers, where you understand, where you can cancel cubes, and only these kind of questions
Cubes.
will
Yeah.
come up.
Okay.
So it shall be 1.13 into 4. So that shall be the radius of X nucleus.
Yes.
So if you multiply, you get 12 and 1, 5 and 4.52 Fermi. So that shall be 4.52 into 10 raised to power minus 15 meters. That shall be the radius of X nucleus, right, Aditi?
Mm-hmm.
Okay. So this is how we sort of calculate the radius of any element's nucleus.
Okay.
Understood or not?
Yeah.
Right? On the same lines, we have another method now. Now, I hope you understand that, when the nucleus, like suppose this is an atom, and there is this particular nucleus. So now what is happening? Let us suppose the element hydrogen, helium, lithium, beryllium, boron, and this can continue up to 118 atomic number. Yes or no?
Mm-hmm.
Because in the periodic table we have 118 elements. What I'm trying to tell you is that hydrogen is there, atomic number 1. Helium is atomic number 2. Lithium is atomic number 3. Beryllium is atomic number 4. Boron is atomic number 5. And
Yes.
so on. So atomic number means what? Again, I'm saying atomic number is the number of protons.
Mm-hmm.
And when atomic number is the number of protons, what exactly does that mean? You tell me. When atomic number is the number of protons, what exactly does that mean? You tell me.
Uh.
It has 5 protons,
Yes. The same.
right? And when
Yeah.
it has protons, definitely its mass number would be, let's suppose, 11. So it has 6 protons.
Mm-hmm.
So as and when you move forward, so the atomic number goes on increasing.
Yes.
And when the atomic number goes on increasing, what does that mean? When atomic number goes on increasing, what does that mean? The number of protons in the nucleus
And
increases. Exactly.
yeah.
And when the number of protons in the nucleus increases, that means the nucleus is getting heavier and heavier.
Have bigger. Yes.
But there comes a stage where this nucleus cannot withstand this heaviness. It cannot bear to be so heavy or so large.
Mm-hmm.
And thereby, these atoms' nucleus becomes unstable.
Okay.
These atoms' nucleus becomes unstable. And which is why, we say that these elements become radioactive.
Radio. Okay.
Radioactive elements are those whose nucleus is unstable. So, radioactive nucleus or radioactive elements are those whose nucleus is unstable. And now this nucleus tries to stabilize itself. How? By alpha decay,
Mm-hmm.
by beta decay, by K capture, and various other methods. Are you understanding my point?
Yes.
So, what is every element doing? You tell me. What is every element doing? Every element is trying to neutralize, is going to stabilize or wants to stabilize its nucleus.
Yes. So
So
they
now
could.
we're going to understand. One is alpha decay. Now, first of all, you understand what is an alpha particle. An alpha particle is a particle which is made up of a group of two protons and two neutrons. It is made up of two protons and two neutrons. This is called alpha particle. So when this group of two protons and two neutrons is made up of, this group is called as alpha particle.
Mm-hmm.
If you look at this particular set of two protons and two neutrons, do you see it is helium nucleus only? Because helium is atomic number 2. Atomic number is the number of protons and mass number 4. And 4 is protons plus neutrons. So 4 shall be 2 plus neutrons. So neutrons shall be 2 in the helium nucleus. Are you understanding?
Mm-hmm.
What is helium? Helium is an atom which consists of 2 protons and the mass number is 4. What is mass
Mm-hmm.
number? Protons plus neutrons.
Protons, neutrons.
And if protons are 2, if you substitute 2 protons in this equation, you are able to calculate the neutrons.
Yes. Yes.
So neutrons are also 2.
Two.
So that means this set of 2 protons and 2 neutrons is nothing but what exactly if I write down helium? It has actually 2 electrons as well.
Yes.
But I am not talking about the electrons. I am talking about the alpha particle. What is alpha particle? It is defined as a set of 2 protons and 2 neutrons.
Two neutrons. Yes.
So when it is defined as a set of 2 protons and 2 neutrons, what exactly does it mean? That ma'am, it is nothing but it is looking like helium nucleus.
Mm-hmm.
So generally, alpha particle is written down as He 2 plus. Why do they write down 2 plus? Because if we have to denote the nucleus, we have to get rid of the electrons.
Mm-hmm.
So we assume that if the electrons would have been removed from helium, only the nucleus would be left.
Mm-hmm.
And this nucleus shall be thereby called as a alpha particle.
Okay.
So going forward, alpha particle would be nothing but just a helium nucleus.
Yeah.
Understood?
Yeah.
Then we have the beta decay. Then we have the beta particle. What is a beta particle? Now, beta particle is nothing but just an electron. Okay? Beta particle is nothing
Okay.
but just an electron. But what exactly happens is that we have, let's suppose we have a proton, we have a neutron. We know that neutrons are neutral.
Mm-hmm.
Neutrons are neutral. And neutral as in that it is going to give me, it is neutral means that its charge is zero. Yes or no? When something is neutral, it does not carry any charge. It has zero charge.
Mm-hmm.
But how does it become a zero charge? So when scientists actually figured out, they realized that, neutron is made up of proton plus electron. And you see, there is a very slight difference in the masses of proton and neutron. The mass of proton is 1.672 into 10 raised to the power minus 27 kg. And the mass of neutron is 1.674 into 10 raised to the power minus 27 kg. So what is that slight difference because of? That slight difference in the mass is that neutron is slightly heavier. So when they subtracted their masses, the mass came exactly to be the mass difference came out exactly to be the mass of the electron.
Mm-hmm.
So they said that neutron is nothing but just made up of protons and electrons. You understand?
Mm-hmm.
And when this happened, so neutrons now going forward, you have to assume that whenever in the nucleus the neutron breaks, it will always break into a proton and an electron.
Right.
And coming out, that electron coming out when a neutron breaks is called as a beta particle. When a neutron breaks is called that electron coming out when a neutron breaks is called as a beta particle.
Mm-hmm.
Are you understanding?
Yeah.
So beta particle is nothing, it's just an electron, but the only difference is that it is being emerging, it emerges out when a neutron breaks. Very simple. You understand my point?
Yes.
So now understand. So when we talk about the beta particle, what exactly does that mean? You have a look here. Similarly, we have gamma radiations, gamma decay, gamma decay. Gamma radiations are nothing but just neutral particles. They have zero mass and zero charge. They have zero charge and zero mass. And they travel with the speed of light. They travel with the speed of light. So this is a gamma decay. So in gamma decay, gamma radiations are released. How these gamma radiations are produced, I'll discuss in length later on. But for now, just understand that in gamma decay, gamma radiations are released. And when gamma radiations are released, when gamma radiations are released, so you need to know the nature of gamma radiations. It basically has zero charge and basically had zero mass.
Uh,
Okay? And they
mm-hmm.
travel with the speed of light, which is 3 into 10 raised to the power 8 meters per second. Simple. You understand my
Mm-hmm.
point?
Yeah.
When we go back to the protons, understand what is the charge of helium nucleus? Tell me. Two neutrons carry zero charge.
Yeah. Two neutrons.
And because we know that helium particle is nothing but just the set of two protons and two neutrons.
Two neutrons.
Neutrons carry no charge.
No.
So protons carry positive charge.
Positive.
That means alpha particles are nothing but
Positive.
positively charged particle.
Yes.
Yes or no? Alpha particles are
Yes.
nothing but just positively charged particle. Are you understanding?
Yes.
So that's the charge. And what is the mass? The mass is very heavy. The mass is 4 times U because the mass of neutron and proton we approximately consider equal to U.
Mm-hmm.
And the value of U is 1.67 into 10 raised to the power minus 27 kg. U is what? Atomic mass unit. Yes or no?
Mm-hmm.
So thereby two protons and two neutrons are there. And that exactly means what? Tell me. That the mass is 4U, very heavy particles made up of two protons and two neutrons.
Two
And
neutrons.
both protons and neutrons are extremely heavy particles. One of the important heavy particles we have.
Mm-hmm.
You understand? So you have to very much be clear with the fact that alpha particles are heaviest actually, then followed by beta particle, and then definitely gamma particles are massless. So alpha particle, so mass of alpha particle, mass of beta particle, and mass of gamma particle is arranged in this order, in the decreasing order. You understand?
Mm-hmm.
So this is alpha decay. Got the point?
Mm-hmm.
Now just understand this part. So for example, when we have alpha decay, beta decay, gamma decay. Now let's understand there is an element, let's suppose uranium 92, 238, and it undergoes alpha decay. Alpha decay, we write on alpha 2, 4. Why 2, 4? Because here at the bottom, what do we write down? Tell me the atomic number. What do you think we write down at the bottom? Atomic number.
Yeah.
And here at the bottom, what am I going to write down again the atomic number?
Atomic number. Yes.
What is atomic number? Number of what is atomic number? The number of
Protons
protons.
plus.
Only
Yeah.
the protons. Yeah. So that means the uranium atom. This is uranium. So uranium shall have 92 protons in it, isn't it?
Hmm.
Uranium shall have 92 protons in it. And this is alpha particle. So alpha particle has two protons in it. That's what we mean by this, right?
Hmm.
So just have a look at the nucleus composition. So this uranium says that it has 92 protons. And what is this here at the top? This is mass number. And mass number is nothing but just the equals to number of protons plus neutrons. So when protons plus neutrons are 238 and protons are 92. So I hope you're understanding that number of neutrons shall be what? 238 minus 92. So neutron shall be 238 minus 92. What would that be? That would be 6.
Hmm.
And that would be
Right.
10 would be 14. So it would have 146 neutrons. Am I right?
Yes.
So you don't have to consider. Obviously, when you draw the electrons as well. So you will draw 92 electrons outside because there are 92 protons. But we are not considered with the number of electrons. I hope you're understanding.
Hmm.
We are considering about the stability of the nucleus. And nucleus is unstable because it is one of the heavy nucleus example that I have taken. Uranium 230 is very, very radioactive.
Yes.
So the reason is why it is radioactive, that because it is very heavy, because it consists of protons and neutrons, which are very, very heavy. And because it is heavy, so what happens is we have learned that protons and protons, they stay together because a part of the protons gets converted into the binding energy. There is a meson which is developed. So this meson, proton 1 gives its meson to proton 2, and proton 2 shall give its meson to proton 1, and so on, which keeps the
Hmm.
two protons together despite the repulsive forces.
Yes.
What is the repulsive force? The positive charge and the positive charge causes repulsion. You understand?
Hmm.
So what exactly does that mean? That ma'am, now the number of protons is so high, so high, so many protons, that no matter how much binding force we have, because the number of protons is so high, the repulsive force is so, so, so high that even the binding force is now unable to keep the protons together.
Hmm.
And that is why the nucleus is very, very unstable. You understand? And which is
Okay.
why now it wants to get rid of extra protons and extra neutrons, because it wants the binding force to become effective.
Yes.
I hope you're understanding the basic logic.
Yes.
Because if you understand this concept, then any question you can attempt. But if you do not understand the
Okay.
logic, you cannot attempt any question. Very sure.
Yeah.
So my point is that if you're discussing the nucleus, you see it has 92 protons and 146 neutrons, so much of repulsion. No matter how much binding force it has, the nucleus is unstable. So in order to stabilize itself, it is going to do what? It is going to get rid of extra protons and extra neutrons. And how is it getting rid of extra protons and extra neutrons, you tell me? By 92 protons
But
and 146 neutrons. So what is it going to do? Tell me.
so
It is going to release
it
two
has to
protons because it's
release the protons and then yes.
exactly. It has to get rid of in the form of helium nucleus. And what is helium nucleus? Alpha particle.
alpha particle because of the two neutrons and two.
So two protons and two neutrons come out of it. So two neutrons when it comes out, a new nucleus is formed.
Yes,
What is a nucleus? That consists of two protons less
protons and
than the
two
uranium's
neutrons and
90
yes.
neutrons, 90 protons,
Mm-hmm.
and two neutrons less. So that shall have 144 neutrons.
144.
So let's suppose some new element would be formed, X, which
Mm-hmm.
has atomic number 90 now. Why? Because the
90
number of protons is the atomic number.
number. Yes.
And what is the mass number added up? What is the mass number? 90 plus 144, it shall be 13.
There.
And no, 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 it shall be what? 90 plus, that shall be
No.
14,
Four.
4, 1, 13 and 14, 234.
Yeah.
So now it's very simple. If you look from here to here, I hope if you look from 92 to 90, and if you look from 238 to 234, don't you see? If I write it down like this, just have a look now. If I write it down like
Mm-hmm.
this, arrow minus minus alpha 24.
Mm-hmm.
So can I not subtract
Oh
90?
yes.
92 minus 2 shall give me 90,
90 and then
and
238
238 minus
minus
4
4.
shall give me 234.
Yes.
So that's how we understand, like the basic mathematical part is this. But do you understand what exactly is happening from the nucleus?
Mm-hmm.
This alpha nucleus is being, removed from the bigger uranium
Mm-hmm.
nucleus.
Yes.
Are you understanding my point?
Yes.
So that is the concept,
Oh.
right? So this is called
Mm-hmm.
alpha decay.
Okay.
So in alpha decay, the nucleus gets rid of the alpha particle. And what is alpha
Mm-hmm.
particle? A set of two protons and two neutrons.
Two neutrons. Yeah.
Understood or not?
Yes.
Right? On the similar
Mm-hmm.
lines, we have a beta decay. A beta decay. Now, when does the beta decay takes place, you see? So you have to understand one very important point, that in alpha decay, both the protons and the neutrons are decreasing. You see, we had initially 92 protons and now we have 90 protons.
Mm-hmm.
And in the 146 neutrons, now we have 144 neutrons. So you write down one line, both protons and neutrons decrease after alpha decay. After alpha decay. Understood or not?
Okay. Yeah.
Similarly, if you are talking about the beta decay, I told you that beta particle is nothing but just a electron.
Yes. In
And
the neutral
that electron, when the
charges. Yeah.
neutron breaks into proton and neutron, proton and electron,
Yes.
that
Yes.
electron, which is produced when neutron breaks into proton and electron.
Mm-hmm.
You understand?
Mm-hmm.
So that is the beta decay. So how does it exactly happen? Let's consider we have again the same element uranium 92. Let's now take an example of the element X that was formed 90 to 34. Now let's suppose it undergoes a beta decay. So before you carry out the beta decay, just understand, make the composition of the nucleus. Let's suppose this black boundary is the nucleus. So here the number that we write at the bottom here, this is my protons, this is my atomic number, yes or no?
Mm-hmm.
An atomic number is nothing but just the number of protons. So the number of protons are 90 protons.
Yes.
And when the number of protons is 90 protons, here what do we have? We have protons plus neutrons.
Mm-hmm.
So when I know the protons plus neutrons is 234, protons I know is 90 in the nucleus. So how many neutrons do you think we have? 234. So neutrons shall be 234 minus 90. So that shall be 4 and 4 and 144 neutrons. So this is the original nucleus composition that I can see from the structure, because I know these values 90 protons and protons plus neutrons is 234. I hope you're understanding.
Yes.
So no matter whatever decay you have to do, you have to first understand one important point, that whichever composition is given to you, first try to figure out how many protons and how many neutrons we have in the nucleus. And obviously the electrons would be there on the outside, isn't it?
Yes.
Because we are not concerned with the electrons, because electrons are not causing any sort of stability or instability. It is the nucleus which is not the stable part. You understand?
Mm-hmm.
So from here, what exactly is going to happen? You tell me. From here, what exactly is going to happen? Just tell me. That ma'am,
So now,
we have to figure out the original composition. We did that.
yes. Yeah.
And now a beta decay has to take place. How does that beta decay take
Right.
place? Just understand. So we
So
know that
now the
when a neutron breaks, understand. So let's suppose when out of 143 neutrons, let's suppose one neutron breaks. So
mm-hmm.
now when one neutron is broken down, so I will be left with 143 neutrons.
43. Mm-hmm.
And that one neutron has broken down into proton plus electron.
Electrons. Yes.
You understand?
Yeah.
So in the nucleus itself, you can see one neutron has been consumed. One neutron, this blue neutron, has died, broken down, and produced one extra proton. So 90 protons were already there, and one proton has come up now. So basically, now I have 91 protons and 143 neutrons left, because out of 144 neutrons, one neutron decomposed, one neutron broken down into proton and electron.
Mm-hmm.
So one proton is actually increasing. Are you understanding?
Yeah.
And that extra electron, this blue electron that is being produced inside the nucleus, that
Mm-hmm.
will come out. And that electron is nothing but a beta particle. So one beta particle shall be released. Beta particle is an electron. I hope you're understanding.
Mm-hmm.
So what is the mass of the electron? We consider the mass of the electron to be zero. We consider that, it is going to be zero. Because electron is so light that, its mass generally we consider to be zero. And here we are writing -1, because here what do we write down? We here write down the atomic number, or here we write down the charge. Now you tell me, here if I write down 90, I hope you understand that in this particular nucleus, there are 90 protons. What does 90 proton mean? That plus 90 charge is there. There's a charge of plus 90, isn't it? Because neutrons do not carry any charge. So basically, plus 90 is representing what? The charge of the X element inside the nucleus. Are you understanding?
Yeah.
So
Yes.
here, if we consider this proton to be 90, this is also the charge of the nucleus of the X element.
Mm-hmm.
Do you understand my point? Are you understanding?
Yes.
Tell me. So this is how this exactly sort of works.
Okay.
Understood?
Yes.
Any doubts in this?
No. I'm just going to take.
Right?
Yes.
So my point here is that this would thereby. So what can I figure out from here? That ma'am, in a beta decay, the protons increases. Now you see from X to whatever Y is being formed, the protons have increased by 1 and the
Mm-hmm.
neutrons have decreased. So in a beta decay, protons increases and neutron decreases. Yes or no? Protons
Mm-hmm.
increases and neutrons decreases. Understood?
Mm-hmm.
So now I will have a new nucleus which will have 91 protons and 2, but you see the mass number? Just check out the mass number, 143 plus 91. When you add it up, it becomes still 234. So mass number has
Yeah.
not changed. So
No.
mass number